Okay, so moving on, let's go. Okay, so some of you are noticing that I am not doing all of the examples. Okay, well, I'm not going to do all the examples, especially the ones that I think that you guys can figure out that are pretty simple. Okay, all right. That doesn't mean it's not important, but it's still something you need to know. But if I think it's easy enough, I'm just going to skip it. Okay. All right, let's go to page 6. Go to page 6. In the middle of page 6, there is the properties of algebra. Okay, you guys have heard this time and time and again. All right, the cumulative property, associative property, identity properties, inverse properties, and the distributive properties. Go ahead and read that, quickly read that over. Okay, shouldn't be anything eye-opening there. You've all seen this before. Okay, properties of the additive inverse. Additive inverse. Okay, that's the blue box on the bottom of page 6. Again, there's no way you get through Algebra 2 without knowing these, so I'm going to assume you know them. Okay. More interestingly, let's talk about the exponents. Okay, this one needs a little bit of brushing up. So let's see if we can understand, we know what these things mean. So let me pick on Shauna. Shauna, tell me what this is. 3 squared, right? Which is 2 times 3.
9.
What?
9.
9. Okay, good. All right. Caden, what is this?
8.
8, because it's 2 times 2 times 2, 8. So obviously, this and this are not the same. Okay, all right. These are exponents, okay? So let's see if we can do, these are a little more fun. Let's see. Sarah. Or do I call you Christina? Which should I call you?
Sarah.
Huh?
Sarah.
Sarah. Okay, so Sarah, what is this?
It is 1/9.
1/9, right? Because this is the same as this.
Yes.
Okay, so 3 squared is 9. 9, 1/9, this is 1/9. Because this is the inverse, correct? A -1 here. Or you can also view it as this squared, because this times this is -2. This time this is -2 also. They both give you the same thing. This is going to be 1/3 squared is 1/9. Okay, are we all good on that? All good on that? Okay, let's see, what else is there? Okay. See who I can pick on. All right, Sam. Sam, are you awake there? Hello?
Slightly awake.
Slightly awake. All right, see if I can fully awake you. What is this?
That's 5.
5, right? Because it's 5, 3, -2. You add these two together, 5 to the first is 5. Or if you want to look at it, this is the same as 5 to the third. This guy is the same as 5 squared, right? So I'm going to have 5 times 5 times 5 on top, 5 times 5 on the bottom. 5, correct? All right, are all good on that? Let's see. Okay, let's flip the page. Let's go to example number 7. Example number 7. Let's see if we can do A together. A, simplify the expressions using that are involving powers. 2 AB cubed. Then here we have 5 B to the 5th. So the 2 is actually within this pair, within here, right there, the parentheses. Okay. Olivia, walk us through this.
Don't you like multiply the exponents together?
Multiply the exponents here. What do you mean? Explain
Like,
yourself.
I don't know, like a to the first times a squared,
Is what?
a squared.
No, okay, so I'm going to have 1 here, right? So I'm going to have, so what I'm going to do is I'm going to take the constants together first, right? 2 times 5 is 10. And I have A1 here times A squared. Then I have B cubed times B to the 5th, right? I have 10. So how many A's do I have together if I do this operation? What do I get, Olivia?
A
To the
cubed.
third, right? 1 plus 2 is 3. What do I get here?
B to the 8th.
B to the 8th, that's correct. Okay, are we good here? Any questions? Thank you, Olivia. Let's do the second one, B. We have UV. U squared V to negative 2. Then I have U to the minus 1. V to the third, correct? V to the third. Okay, so let's see, who should I pick on? Eason. How am I going to do this? Eason?
I'm not sure.
Not sure. Okay, so let's look at the u's, okay? If I have the u's, I'm going to have u squared over this, correct?
Yeah.
And on the v's, I'm going to have...
Oh, those are V's?
Yeah, this is a v, this is a u, right?
Okay.
Okay. So the u's, I have what? I have u2. And since this is in the bottom, it's in the denominator, I have to subtract this, right? So I'm going to subtract the negative 1. And on the v's, I start with negative 2. I'm going to subtract
+3.
3, right?
Oh.
So what do I get here?
Use 3.
U to the third, correct?
Yep.
And then v to the
-5.
negative 5, which is the same as u to the third, v to the 5th. Everybody get that? Are we good with that? Because it's 5th, negative 5th. This is what I end up getting.
Yeah.
All right. Move on to the next one. I have x squared over 2 to the negative third Brady, tell me how to do this.
You start out by flipping the fraction to make it.
Okay, so good job. So we're gonna go ahead. I think what Brady is saying is that we're gonna do -1, and then we're gonna do this to the cubed, correct? Is that what we're saying?
Yeah.
Okay, so we're gonna do -1. This was the flipping, what he was talking about. So I'm gonna get 2 over x squared to the third, and then continue on for me.
You put the exponents into both of the
So I'm gonna
numbers
get
in the
2 to the thirds, x to the sixth, right? 2 times 3 is 6. So I'm gonna end up with 8 over x to the sixth, correct?
Yeah.
All right, good job, good job. Okay, so that's that. So let's talk about the scientific notation. That's the last thing we're going to talk about today. Scientific notation. Scientific notation is when you have a number like this, 5400, instead of writing all these numbers out, the scientists got lazy and said, well, I'm not going to write this. I'm going to call this 5.4 times 10 to the sixth, right?
Yep.
I have since this is the true decimal point, I'm going to count my decimal. I'm going to have 1, 2, 3, 4, 5, 6. Okay, that's where that 6 over here comes from. Okay, so in a true scientific notation, this first number here is always going to have only one number to the left of the decimal. Okay, in other words, if I have a number that looks like this, it's going to look like this. Okay, if I had a number that looked like this, it's going to look like this. Does that make sense? Are we good? So on a true scientific notation, again, you'll only have one number. You have to have one number to the left of the decimal. Everything else is to the right of the decimal. Okay? Because I can actually write this as this, right? This is also the same as this. Okay? Because if I go 1, 2, 3, 4, 5, right? But this is not a scientific notation because from the decimal point, I have 1 and 2. I have 2 digits to the left of the decimal point, okay? I can only have 1 to make it a true, actually this would be what I'm missing a number here, I guess, right? It look like that, okay? All right. Everybody see what I'm saying here? This is what a scientific notation is. And it works the other way too, right? 0.0055. I would go from here. I'm going to count the other way. I'm going to go 1, 2, 3. So it's times 10 to the negative third. Okay, because I'm going the other direction now, right? All right. And the beauty of it is that if I have to multiply, let's say this number times this number, it's instead of going 508, oops, 5408000 times 0.0055, what I do is now I say this is 5.408 times 10 to the sixth, and this guy is 5.5 times 10 to the negative third. I do this times this, okay, I'm going to get, I don't know what I get. I'm going to get, let's say I'm going to get 29.46. I'm making this up, right? So I'm going to get 29.4608. And then I can do this, and this is going to be what? 10 to the third. Is this a scientific notation here?
Nope.
Nope, why not?
Has to be 2.94.
Exactly. So it has to be 2.9468 times 10 to the fourth. You have to make that one correction to put the answer into a scientific notation. Okay? All right. So we are done with P-1. P-1 is now due.